Soil structure is when soil particles get glued together into what we call aggregates or PEDs. The aggregates or PEDs are glued together with organic matter, aluminum oxide, iron oxide, or calcium. Aggregates also have many different shapes. They can be granular, prismatic, platy, blocky, columnar, or massive. Granular aggregates tend to be more or less round in shape. They're not a perfect sphere, but they are irregular. They are the most common type of aggregate that we see in the A horizon. This is an example of a granular aggregate. Actually, it's many granular aggregates stuck together into one very large one. The aggregates themselves are relatively small, a few millimeters in diameter, but they are glued together into this much larger aggregate. The aggregates are round in shape and have large pores between them. The advantage of having granular aggregates in the A horizon is that we get very large pores between the aggregates as well as very small pores within the aggregates. The large pores between aggregates allow water to flow through fairly easily and allow air to get into the soil. The very small pores within the aggregates will hold on to water, and plants will be able to use that water as the soil dries out. The amount of organic matter will determine how easily or how difficult it is to break aggregates apart. This aggregate has lots of organic matter in it. It is quite dark. But if we compare it to this aggregate is much lighter in color, and it has much less organic matter. And if we look closely, we can see that this low organic matter aggregate does not have large pores or many large pores in it, and it has a lot of very, very small pores. If we were to get this low organic matter aggregate wet, it's very likely that the particles would fall apart, the aggregates would not stick together, and when the soil particles fall apart, that's called slaking, and the soil dries out again, we get a soil structure that is very hard and difficult for plant roots to grow through. Platy structure is found in temperate areas where you have lots of freezing and thawing. It's very often found in medium texture soils, silt loams, and loams, and what it looks like is a stack of plates on top of each other, hence the name platy structure. The plates can be anywhere from about 1 millimeter in thickness to about 1 centimeter in thickness, and the areas of weakness between the plates run parallel to the soil surface. Blocky structure is made up of cube-shaped aggregates. The cubes can be as small as about 1/2 of a centimeter per side, up to several centimeters per side. Blocky aggregates are typically found in the B horizon of soils, usually in prairie soils and in areas of grasslands. Prismatic structure has aggregates that are long and they are shaped like prisms. They are often 3-sided, sometimes 4-sided, but they are quite long, looking like a prism. Columnar structure is also found in the B horizon, and they are long, polygonal shaped aggregates that are several centimeters long, maybe 1/2 meter long even, and they are either flat-topped or round-topped and have 4 sides or many sides, or they're shaped like polygons. Massive structure is found where there's very little organic matter typically, and when the soil gets wet, the aggregates all break down, the soil runs together, and we get a very hard, massive soil that plant roots find it very difficult to grow through, and so it's very difficult to grow a good crop on those types of soils. Single grain structure is found mostly in sandy soils. Single grain structure essentially means that the individual soil particles aren't glued together at all, and they are very loose and can flow very easily. If an aggregate stays together when it gets wet, we call it a water-stable aggregate, and that means that that structure stays together and does not fall apart, so we keep the large pores between the aggregates, and we also keep the small pores within the aggregates, and so the soil can undergo lots of wetting and drying cycles and still remain in a condition that is very good for plant growth.